What we are starting today is Chapter 5. Now, one of the main topics in Chapter 5 is, well, the topic in Chapter 5 is triangles. So mainly what we're going to be talking about in Chapter 5 is triangles and going over properties of triangles. Now, this here for triangles will not be the only chapter on triangles. We're going to talk about triangles pretty much for the rest of the year. Now, the main topics that we talk about won't specifically revolve around triangles themselves, but triangles will come up in some shape or form again and again and again. It ends up being that triangles are a very key building block to a lot of different things. If you think about the structure, if you've ever been into the attic or the roof of your house, it's a triangle. It is a solid structure for supporting weight. If you think about main bridges, the main bridge or for a suspension bridge is a triangle. Triangles are incredibly useful and incredibly helpful in a lot of different ways. So they will be coming up again and again throughout the rest of the year. Now, what we're looking at triangles today is some of the real basic principles. The first thing we have is really just classifying triangles based on their sides. So we have three different types of triangles that we could have: scalene, isosceles, or equilateral. Now, doing the vocab sheet yesterday, we know that a scalene triangle is a triangle that what? Has no congruent sides. It has no congruent sides. Isosceles has at least two, and equilateral has all three. So scalene has none, isosceles has two, and equilateral has three. And really, if we look at the term equilateral, where else do we see equal, the same, equal, lateral is our sides. So we're saying all the sides are the same, they're all equal. Now we can also classify the triangle based off the angles themselves. Now the first one we have is an acute triangle. Well, it's going to have three acute angles. If it's a right triangle, it has what? One right angle. Obtuse has one obtuse. And equilateral has three congruent angles. Now, what is the sum of the interior angles of a triangle? They all add up to be 180. So they all add up to be 180 degrees. Well, we have three angles that would add up to be 180, yes? For a right triangle, well, we know one of the angles has to be 90, yes? So we can say 180 minus 90. Well, that leaves us with 90 degrees, yes? For how many more angles? Well, two, the other two, yes? Could one of those other two angles be 90 degrees? Well, if one of them is, another one's 90, well, how much do I have left for the third angle? 0, right? So, okay, if one of the angles is 90, we can kind of see that the other two cannot be 90 degrees, yes? Well, let's just say 100 for our obtuse, because 100 is an obtuse angle, yes? Because it's greater than 90 degrees. Well, we said the total was 180. That means the other two angles have to add up to be 80 degrees. Could either one of those two angles be obtuse? Well, no, because 80 is already acute. The others have to be acute. So with right and obtuse triangles, if we have a right angle, well, The other two have to be acute, just by definition. For obtuse, well, as we just saw, if we have one obtuse angle, the others are going to be acute. Even if we took 91 degrees, well, the others would be 99 degrees. But again, we have to cut it into two. There's no way that we could actually have another obtuse angle and that still work. And the last one is an equilateral triangle. All three angles are going to be the same. In this triangle here, we want to classify it by its sides, and then we'll measure the angles. I'll measure them here. When we look at this here, it's kind of hard to see, especially on the printout, but we do have a line here and here kind of on the figure, which is telling us those two lines are. So how can I name this based off the sides? It's isosceles, because isosceles has at least two congruent sides. Now, if we took our protractor and measured it, well, the color that we can see, this here is going to be 55, and it works out that these here are both 55 degrees. If we took a protractor and measured it, they would both be 55 degrees. And this top angle will be 70. So how can I classify it based off the angles? Acute. So this would be an isosceles acute triangle. Could we have said an acute isosceles triangle? Yeah. Because again, we're just basing it off, naming it based off the sides and angles. That's it. Questions on this here? Now we're looking at this triangle here. Huh? It is right. And how did you know that it was a right triangle? It has a right angle, so it's automatically a right triangle. Are we given the measures of any of the side lengths? So any of the lengths of the sides, do we know what they are? So we can say it's what? The scalene, a right scalene triangle. And that's it. Questions on this here? Well, let's look at the next one. The next few, because we're going to do this on a few more. So if we look at this first one here, we're told that the side lengths are A, B, and C, and we're given the figure. So how can we classify this triangle? So it is right. So that would name it based off the angles. What can we say about the sides? Scalene. It's a right scalene triangle. We know it's a right triangle because of the right angle. And since all three side lengths are different, it's scalene. How about triangle number 2? I would go obtuse. Normally we would need a little bit more information than that because we would need to know for certain that that top angle is greater than 90 degrees. But for this here in the assignment tonight, I'll accept that because it does look it that way, but for most of the time we'll need more evidence than this. And we can say what else? And we know it's scaling because it gave us the side lengths as A, B, and C. How about number 3? Yep. Yes. And we know it's isosceles because two of the sides have a length of B. Questions on this here? How about number 7? Yes. And what can we say about the angles? And we really could have said equilateral, equiangular for this one here, and the reasons behind it, we will delve into them eventually, but those two normally do go together. How about number 8? And we'll do one last one. Yes. Any other questions on any of these here? Okay. Let's move on to the next part, because I feel like y'all feel comfortable with these here. So we're going to look at these last few. Classify triangle OPQ by its sides, then determine whether it is a right triangle. So we need to determine based off its side lengths, either we're going to have 2 congruent sides, 3 congruent sides, or none. And when we're determining it based off its sides, we need to know the what? The distance, the length of the sides, yes? Well, luckily we do have the distance formula, because the distance formula will tell me the overall distance between any 2 points. Well, as we see in this figure here, do we give a straight line, or do they give us a straight line for any of the sides of the triangle? Well, no, they're all on a diagonal of some kind. But luckily with the distance formula, we just have to plug in the x values and the y values, because it's x2 minus x1 plus y2 minus y1 squared. So we can say from P to Q. We can do that one first. Well, the x values are 6 and -1. So we can say -1 minus 6. And the y values are 2 and 3. So we can say 2 minus 3. Well, at this point here, we can just type the whole thing into the calculator and it would give us an answer, yes? Now, if we did this by hand, well, -1 minus 6 would just be -7 squared. 2 minus 3 is -1 squared. which would be 49 plus 1, which is the square root of 50, or 5 square root of 2. Is the distance from P to Q. Any questions on how we found the first distance? Okay, well, I'm going to erase this because I don't quite have the space to have all of them up at once. Well, we're just going to use the distance formula again. And we can just say from P to O. So we're going to put our x values, subtract them squared, plus our y values squared. Well, I should just write this in so that we have it x2 minus x1 squared plus y2 minus y1 squared. Now, the x values for this here are -1 and 0. So we have -1 minus 0. Our y values are 2 and 0. And again, at this point, just like we could do with the last one, we could type it in at this point just as we see it here. Now, if we did this one by hand, well, -1 minus 0 is just squared, plus 2 minus 0 is just 2 squared. Well, -1 squared is 1, 2 squared is 1 plus 4 is. So for this distance here, we have the square root of 5. Now that leaves us with the last length that we do need to find. Now for 0 to Q, well, our x values are 6 and 0. So we can say 6 minus 0 squared, plus our y values are 3 and 0. 3 minus 0 squared. Again, if we do this by hand, we'll end up with 6 squared plus 3 squared, because 6 minus 0 is still 6. 3 minus 0 is 3. Now 6 squared is plus 9, which would be the square root of, which actually works out to be 3 square root of 5. So what can we say about the side lengths of this triangle here? It's scalene, because are any of them the same? Now it did ask for one other thing. Determine whether it is a right triangle. So looking at this figure, if it was a right triangle, the right angle would most likely be here, yes? Okay. I'm going to erase this here. Now, what way have we learned so far to figure out if we do have a right angle? Because we did use it last chapter, but we didn't necessarily say it was a right angle, but we used it to find a certain type of line. Slope, yes, because if two lines intersect at a right angle, they are what? Perpendicular, because perpendicular lines intersect at a right angle. So here, if I find the slope of PO and QO, and they are opposite reciprocals, their slopes are opposite reciprocals, then it is going to be a right triangle because they would intersect at a right angle. So we can use the slope formula. 2 minus y1 over x2 minus x1. So we can call it PO. So from P to O, what are our y values? What would the x values be? Well, 0 minus negative 1, which would be 0 plus 1. Well, 0 minus 2 is negative 2. The negative and negative on bottom would be plus, so 0 plus 1 is. So we have a slope of negative 2. If these are going to be perpendicular to each other, what would the other slope have to be? Positive 1/2, because we have to change the sign and flip. Since it's negative, our other slope would need to be positive. And to flip it, it would go from 2 to 1/2. So if we look at OQ, its slope, well, the y values are 3 minus 0, almost. Since we started with 3, 6 has to go first. Whichever y value we put first, its corresponding x value has to go first. Well, 3 minus 0 is 6 minus 0 is, and 3 divided by 6 is the same as 1/2. So are these opposite reciprocals? Yes. Again, another way we can check it is if I do take negative 2 and multiply it by 1/2. If I multiply the two slopes and get a product of negative 1, it would be the same thing. And if we multiply them, well, the negative 2 will multiply by the numerator, which would be negative 2 over 2, which is negative. So, yes, it's right. So this one here would be a right triangle. Questions on this here? We ready for the next one? Yes. Triangle ABC has vertices of A is 0, 0. B is 3, 3. And C is negative 3, 3. Classify the triangle by its sides, then determine if it is a right triangle. So we need to find the distance of all three sides, yes? Well, across the top, well, wait a minute. This is a straight line, isn't it? Can we count the axes? Or just count along the grid? 1, 2, 3. Yep. Yeah, because 1, 2, 3. 1, 2, 3. So that gives us a total of 6. So whenever it's on a straight line, it is kind of nice. I will give you graph paper for the assignment so that you can graph them out and see if there is any on a straight line. We can take that into account. But the other two, unfortunately, are not. So we do need to use the distance formula. Really, we're subtracting the x values, subtracting the y values, and squaring. So we can go from C to A. Well, the x values are negative 3 and 0. So we can say negative 3 minus the y values are 3 and 0. So we could say negative 3 minus 0 and 3 minus 0. Questions on this here? Well, at this point, we could plug the whole thing into the calculator and get our answer. Or if we did it by hand, -3 minus 0 is just -3 squared. 3 minus 0 is just 3. Now, -3 squared would be +9, plus 3 squared is still +9. 9 plus 9 is 18, and if we reduce the radical, we will get 3 square root of 2. Yes? Any questions on how we got this here? Well, square root of 18, well, 18 is the same as 2 times 9. Well, what's the square root of 9? 3. It comes out. We can't take the square root of 2, so it stays inside the radical. Questions on this here? Well, we still have to find the distance of the other side. Distance is equal to the square root. What are our x values from A to B? So we can say 3 minus 0 squared plus our y values are. Now again, we could type this into the calculator at this point. We can do second square root parentheses 3 minus 0, close parentheses squared, plus 3 minus 0 in parentheses squared, and hit enter, and it would give us the answer. Well, 3 minus 0 is 3. 3 minus 0 is 3. Well, 3 squared is 9. 3 squared is 9, which would give us the square root of 18, which is so what can we say for certain about this triangle? It is isosceles. Now we need to determine if it is a right triangle. Yes. Well, looking at these three angles here, this here is where the biggest angle is at. Yes? So most likely, if it's going to be a right triangle, it's going to be there. And well, to determine that, we just need to find the slopes of the two lines that intersect at that point. And we can do that with the slope formula. So we can go CA first. M is equal to y2 minus y1. What are our y values? Almost, because 3 and 0. 3 minus 0. -3 is the x. Well, 3 minus 0 is -3 minus 0 is -3. Yes? 3 divided by -3 is -1. So if we want this to be a right angle for these two lines to be perpendicular, we need the opposite reciprocal. So since our one slope is negative, the other is going to be positive. If I flip 1, it becomes what? 1 over, well, 1 divided by 1 is still 1. So the perpendicular or opposite reciprocal of -1 is +1, yes? And as we just said, the way we checked the last one, just to make sure the slopes were opposite reciprocals, is if I multiply the two together, I get a slope of -1. I get the product of the two slopes is -1. Well, the one slope is already -1. What's the only number that times -1 that would give me -1? Just 1. Because if we multiply anything by 1, we get the number back. So we just need for BA's slope to be 1. Because if it's a +1, then these two slopes are opposite reciprocals. They are perpendicular. Well, the y value at point B is 3, and the y value at point A is still 0. I'm putting it second because it is 0. Our x value is 3 minus so this is an isosceles and that's it. Questions on this here? What do we think of this so far? Not bad. A little tedious. A little monotonous. Could we say this is tedious and monotonous? Monotonous, it is the same thing over and over again. So tedious and monotonous are the same thing. Do we need to see another example of one of these? Because that's all we're doing for today. Because I just provided more examples in here just in case we needed them. So the big things with this here is having an understanding of what isosceles, equilateral, and scalene means, as well as acute, right, obtuse, and equal angular mean. And especially for the ACT, for those of y'all that took it, they will sometimes throw that in, and it'll be in a word problem. They won't give you the picture, but given the following isosceles triangle, give us, or isosceles triangle, and the base is 4 feet, and the perimeter is 17, what are the missing sides? Well, perimeter is all the sides added together, yes? Well, by definition, isosceles means what? Two sides are congruent. So the missing sides, we know, are going to be the same. The whole thing adds up to be 17. Okay, we can work from there. So sometimes, especially with geometry, knowing what the words mean is helpful. And also for this here, our slope and the distance formula are both helpful.